Welcome. So today we'll discuss about second norm. Before going into second norm, we'll see what all the condition we discussed for first norm, or to eliminate the duplicate records in your first norm. So first norm should have all column contains atomic values. So all column should have atomic values, and each row should be unique. Row should be unique. Okay, there should not be any duplicate rows, and each column should have unique name, and the order of which the data is stored doesn't matter. So these are the four conditions we looked into for a first norm. Okay, so now we'll discuss about the second norm. Second norm is also called as eliminating partial dependency. So the condition for second norm is the table should be a first norm table. It should satisfy first norm, and there should not be a partial dependency. No partial dependency should be there. That is, the non-key attribute must depend on whole composite key. It should be a fully dependency. It should not be a partial dependency. It should depend on whole composite key. Okay. And this is applicable only if the primary key has multiple columns. Okay. So the condition for second norm is it should already be a first norm, and there should not be any partial dependency. That is, it should be a full dependency. Non-key attributes must depend upon the whole composite key. So that is the condition for your second norm. So we'll see with an example. So here in this first condition, we have given the composite key as student ID and course ID, and a non-key attribute is teacher. Okay, so we have student ID, course ID, and a non-key attribute teacher. So the condition for this second norm is this non-key attribute should depend wholly on the composite key. It should depend wholly on the composite key. It should not be a partial dependent. Okay. So instead of having a bigger table like this and getting confusion between your student ID, course and teacher, we can split this into two tables like student ID and the course ID, and course ID and teacher. You can name this attribute table as student course, and this course ID and teacher table as course. So we can split this table as this. Why? Because here this teacher may depend on this student, or it can depend on the course ID. So this becomes a partial dependency, which is not acceptable in second norm. So what I do is I separate this, decompose into smaller table. Now student ID and course ID and teacher. If you see here, this teacher is fully depending on this course ID. Okay, it depends only on the course ID. So it is fully dependent on the course ID. So this is a property of your second norm. If you want to say clearly, I'll show you one more example for that. Let us take a table, student table, which is having the attribute student ID, student name and branch, and another table with subject ID and subject name. Okay, and also we'll have another table to score, to mark the score of a student like this: student ID, subject ID, marks and teacher name. If you see here in this table, the primary key is student ID and the subject ID. Okay, because both these information are required to select any of the row or data. So the student ID and the subject ID both is the primary key. So to select any of the row. Okay, but in score table, right, we have another column called teacher, right? So this teacher depends upon the subject information. or just the subject ID, right? So I can separate that table, right? So instead of having student ID, subject ID, marks and teacher name, so teacher name is only going to depend upon the subject, right? So which teacher is going to take which subject, it is going to depend only on the subject ID. So I can still further divide this table, right? So column teacher name should be in the subject table, right? And the entire table will be normalized then. Understood? So now what I can do, I can divide the subject like this. So I can have subject ID, subject name and teacher name, student ID, subject ID and mark, right? Because the teacher name is depending upon the subject. Got it? The column teacher name should be in the subject table. And like that I can decompose. So this is your second norm. And moving to your third norm, the condition for third norm is it should be a second norm function. It should be a second norm. And also it should not have any transitive dependency. Okay, so that is the non-key attribute should not depend upon the other non-key attributes. Okay, so the condition for second norm is it should already be a second norm and it should not have any transitive dependency. That is, the non-key attribute should not depend upon the another non-key attributes. It should be independent of each other. So that is the transitive property, right? So we'll see with an example. So here in this employee, in this table, employee ID, employee name, department ID and department name, these are the attributes. Here if you see, this department name depends upon the department ID and not directly depending upon the employee ID, right? So it is a transitive dependency, right? So how to fix this? I can separate into two tables, employee table separately, department table separately. So employee table, I'll have employee ID, employee name and department ID, and department, I will have department ID and department name. So there should not be any transitive dependency, whereas here it is transitive dependency, right? So if I know the department ID, I can tell which department it is, or if I know the employee ID, I can tell which department he belongs to. So it is dependent, right? So it should not be a transitive dependency. So we will further decompose this table into two smaller tables where we have employee table separately and department table separately. So this is an example for your third norm. So if you take an example here, see the score tables, it is having student ID, student subject ID, mark, exam type and total mark. Okay, so in this table the column name exam type, right? Exam type depends on both your subject ID as well as the student ID, because a student from CSE branch can students can be in CSE department, he is taking the theory subject, or he can be in mechanical branch, he can also take a theory subject. So based on that, they may have a different exam type for different subjects. So CSE students may have both practical and theory for this particular subject, whereas mechanical branch students may have only theory exam for compiler. So what we do is further we divide this. Okay, so your mark is depending upon the type of exam, whether it is a practical exam or a theory exam. So this mark depends upon this type, right? And this exam type is not a part of the primary key. Okay, so because primary key is only student ID and the subject ID. So here again it is dependent, right? If I know the subject ID, I can tell whether it is a theory or not, whether it is a theory or practical. So it is a transitive dependency. So we should break that transitive dependency property. So I can again further decompose this into smaller one. Okay, so I will put one more table like exam type. So exam type ID, exam type, whether it is a practical or theory, what is the mark. I am adding here one more column, a set duration column. So like this I can divide into smaller tables. Next is the Bcnf, Boy Squad normal form. So this form is actually stricter than the 3NF. So here it actually deals with some anomaly which is not handled in your third norm. Okay, so that is why it is said as it is stricter than third norm. Okay, so the anomalies which is not being handled in the third norm, that is handled in this Bcnf. So the condition here is every functional dependency, that is x determines y, x must be a super key. Okay, so that is the condition. It is stricter than third norm, and the functional dependency, for every functional dependency x determines y, so this x should be a super key. And also this third norm function table does not have any multiple overlapping candidate. Does not have any multiple overlapping candidate keys. Only if this is the condition, it is said to be Bcnf. Okay, so your third norm table which does not have any multiple overlapping candidate key is said to be a Bcnf. Okay, we'll see with an example. So here this course, teacher and room, it is not a Bcnf. What is the rules? It should not have any multiple overlapping, right? So here the course is taught by one teacher and the teacher uses only one room, but teacher is not a super key. Here which is the super key? Course is the super key. Okay, so we can decompose like course as separate table and teacher as separate, teacher room as separate table. So course is having course ID and teacher room is having the teacher name and the room. So I can further divide like this. So in this table course is going to be the super key, and in this table teacher is going to be the super key, right? And next is the fourth norm. This fourth norm actually removes the multi-value dependency. Fourth norm removes multi-value dependency. Okay, otherwise we can say a table is in fourth norm if this Bcnf has no multi-value dependency. Again, we can otherwise say a table should not store two independent multi-valued facts about the same key. It should not have two independent multi-value facts about the same key. Okay, so a multi-value dependency occurs when one attribute determines the other and both attributes are independent of all other attributes in the table. Only then we can say that is a multi-value dependency. Okay, so we have to remove this multi-value dependency in your fourth norm. For example, let us consider a table where your student ID, language and hobby are the attributes. Okay, so here if student is having multiple hobbies, one particular student is interested in basketball, he might be interested in cricket, he might be interested in throw ball. So if a student is having multiple hobbies, so there exists the multi-value. Okay, so for this we have to decompose into smaller tables. How I can decompose? I can have like student ID and hobby as one table and student ID and language as another table. Like that I can decompose. Okay, so I can have multiple hobbies and I can have students can have multiple language. So it is going to have a multi-value dependency there. To resolve this, what we do is split the table into separate tables. So for separately for language and separately for student hobbies. So this is fourth norm. And next is fifth norm. Fifth norm is also called as project join norm form. Okay, your fifth norm is also called as project join norm form. So actually this fifth norm is deals with the joint dependency. So it will decompose the table so that it can be joined without creating tuples. Okay, so fifth norm is achieved when the table is 4. It should already be a fourth norm, and all joint dependencies are removed. It should be removed. All joint dependencies should be removed. Okay, and this fifth norm ensures that every table is fully decomposed into smaller tables that are logically connected without losing any information. Okay, so it should be fully decomposed into smaller tables, but it should be logically connected without losing any information. For example, here, if the table contains student ID, course and instructor, okay, so there is a discrepancy when the combination of these columns are needed for specific relationship, right? So I can split into smaller tables to remove this redundancy. I can have student ID and instructor, course and instructor as a separate table, right? Or student ID and course as separate table, student ID and instructor as separate table. I can further divide this small table into smaller one to avoid the joint dependencies. So in summary, we can see, so in first norm, what is the problem? Repeating of groups, or we can say eliminating duplicate records. That was done in your first norm. In second norm, what we did? We eliminated partial dependency. So eliminated partial dependency. And in third norm, we eliminated this transitive dependencies. There should not be any transitive dependency. So here there should not be any, no partial dependency. Here no transitive dependency. And in your fourth norm, so for every functional dependency, your X determines Y. X should be a super key, right? So this non-super key dependency is been removed. And in fourth one, multi-value dependency is removed. And in fifth norm, spurious table due to joint dependency. Joint dependency was eliminated. So these are the different norms. So first norm, it eliminates duplicate records. Second norm, no partial dependency. Third norm, no transitive dependency. And Bcnf, non-super key dependency is eliminated. In fourth norm, multi-value dependency is eliminated. In fifth norm, joint dependency is eliminated. Thank you.